Good afternoon. We're kind of in the home stretch here. I think I'm here between us and the closing and beer. Beer, yeah. John has actually brought all the beer. Okay, so thanks for attending. I'm going to actually cram in two topics today. So it is the Project Mercury case study that was done with the Green Grid, as well as the Data Center Pulse Top 10. Okay? So we're going to buzz through these things, and I'm going to try and leave some time for questions at the end as well, because I'm sure there will be a couple that once you see some numbers. All right, so let me see if I can flip through this here. I want to start where eBay is right now. So who here uses eBay? Okay, who here uses the mobile app? All right then. So you see that car? That was sold on eBay for $369,000, okay? It's a Porsche Carrera GT. The interesting part of this transaction was it was actually sold on an iPhone using Buy It Now. Okay, think about that transaction itself. Somebody said, that's a really cool car, and I'm going to spend $369,000 by clicking a button on my mobile device. The way that people are shopping is changing, okay? This is one example. It is one of the highest priced items that was ever sold through a mobile device, and it'll continue to be doing these things. But let me tell you the drivers around Project Mercury. So Project Mercury was the data center we built in Phoenix, Arizona, and it was to augment our Tier 4 facility. And it was part of our larger strategy to consolidate and actually create a multi-tier environment that actually maps applications to the right resiliency in a data center. Okay? So eBay has purchased 13 companies in the last 12 months. We've just did $68 billion worth of transactions last year, $4 billion higher than the year before. We have broken the 100 million user mark, active users on the site. We also broke the 300 million listing mark, so that's how many items are for sale at any given second of any day of the year. Also, 50% of the equipment we have underneath all of this needed to be refreshed last year. Half of our infrastructure, our server infrastructure, storage infrastructure, and network infrastructure needed to be changed. On top of that, because of the business demand and also some investments we've made in rewriting certain code and investment in other things such as Hadoop, we have had the largest demand for equipment in our history in one 12-month period. So how do you deliver tens of thousands of devices very quickly to basically match up to what's going on in the business? So Project Mercury. This is, we love actually challenging things, okay? And the strategy for us was we want to go into 3 locations that can scale to 50 megawatts each. When are we going to consume 50 megawatts in a site? Don't know. But the whole point is we'll continue to grow, and we're going to continue to make sure we're ahead of that demand. Project Mercury was the augmentation of our current Tier 4 facility in Phoenix, Arizona. And we believe that 80% of our applications actually can live in Tier 2. Let that sink in for a second. We had all of our applications living in Tier 4 before. Very expensive portfolio. Once we started looking at it from a resiliency standpoint, we could actually point a lot of these things like search and some front end and some other components to live in a Tier 2 center. Okay? So, there we go. The paper was released in February, and it really documents what the business drivers were, as I was just mentioning, goes through the strategy of how we approach this, the implementation, and then it starts sharing the results of the design and the strategy that we put in place. This is a vendor-independent paper, so we're not talking about anybody specific, but it does go into the modules and the solutions and the challenges across all of it. This is the key. Industry alignment, or alignment of organizations inside of your business, was the thing that actually got us there. Facilities and IT inside of our business are under the same VP. They have the same budget. They have the same goals, and they're all driving to the same efficiency targets. It's not silos of facilities and silos of IT working independently and basically conflicting with each other. That organizational alignment was extremely important. Okay? From there, we could have the right conversations. So the next component was TCO-driven decisions. So I'm not going to go have the IT guys just buy the equipment they think is the right one for whatever application they're going to do. I'm not going to have the data center guys go back and design their infrastructure based on what they think is best for the environment itself, the physical environment. We're going to bring them back together and come up with the answer from a total cost of ownership, because we're all under the same budget, all under the same goals. What's the right investment? Okay, so we make our decisions based on actual TCO. The other side was PUE, using that as a driver for design of infrastructure. That's important. It's not an afterthought. It's not something you measure when you're done. It literally is, I have a target. You're going to meet that. I have success criteria for the design and the implementation construction guys that you're going to actually meet those numbers. If you don't, there's penalties. Pretty simple. So use it as the driver. Then you start to look back at data center maturity model. And I look at this as really a map. So where are you in the application of best practices and innovative thinking? It allows you to take all of these concepts, all the things you do, and just see where you stand. So I'll be showing you some of the results on that as well. So let's go into each one of these. Alignment. This gives you a holistic impact in your infrastructure. Okay, so under the same budget, under the same goals, allows us to truly look at, when we buy a server, how much does it truly cost us? Okay, I mentioned that right-sizing applications was the key first. What can fit in Tier 2? What fits in Tier 4? Then we started looking at, what equipment do we buy? We took the top 15 SKUs or configurations in our infrastructure and we consolidated them to 2. Okay, that represents 80% of the hardware that we purchase every year. That's important. There's still 20% that's the exception, and we will always have that exception because not everything fits into one box. But 80% of the infrastructure being on the same platform, the same configuration, and the same packaging and volume suddenly gives you some incredible opportunities to streamline all that and optimize for efficiency. So we made our decisions basically on the hardware itself based on its total consumption of power over its useful life for 3 years, running our workload. Okay, so think of the building and the depreciation, all the overhead of the data center, a cost per megawatt. Think of the IT components and the actual cost of the server and the watt is consumed. Roll those together and you have a cost per watt for what that work's going to do. That's how we chose the vendors that won these bids. Okay? Whoever had the most efficient, not the lowest cost, not the sexiest, not the whatever, it literally was the right solution for our business. The other thing is, once we start getting all these together and we're making decisions, we established a brand new supply chain organization inside of our company. We never had it before. This is looking at what the technology refresh map is, looking at what the new demand is, and creating a real forecast. Wow, what a concept. Before it was, we're always trying to catch up with what the demand is, and you're ordering equipment and they already need it, those kind of things. So by standardizing that equipment and now handing that to a supply chain that allows us to say, well, I'm not buying 100, I'm going to buy 10,000. What does that look like? And then I'm going to package them all in certain manners that allows me to get efficiency. Suddenly, containers became a viable option for us because you're doing them almost at 2,000 servers at a time. Interesting. So we now have found the sweet spot. It's 96 servers in a cabinet. It's 4 switches. It's 28.8 kilowatts. It's 3,500 pounds. We're buying a rack like that. Well, guess what? That's the same thing in a container if it's rolling into a rack inside, or a rack rolling in the ground floor. We found that sweet spot. We give it to supply chain, and we've optimized all those costs, delivery times. We have a forecast. We can actually get ahead of it all, cash it up, and create real infrastructure as a service. All the hardware's there. What application do you want to run on it? Okay? This is really what the promise of cloud was supposed to be. All right. It cut our equipment delivery literally from months, because it would take weeks and weeks and weeks just to go procure, get the orders in, make sure everything's working, the delays. It cut that down to minutes, because now we have caches of equipment that I can say, make that a search node, make that a front-end node. Great. Infrastructure as a service can take over that, and in minutes I can have applications added to a pool or a new thing added to for a function. The bottom one is very important. Right-sizing the apps, actually building the right-size tier data center, and looking at ultimate efficiency, cut our OpEx for running that in half. 50% reduction in our OpEx. I pay those bills, so we know exactly what it is. It also cut the CapEx in half, because I don't need to build as much redundancy inside of my centers. Tier 2 works great for 80% of my applications. Wow, huge savings across the board when it comes to that. Okay? Next one, PUE is the design driver. We went back and aligned both our design team and our construction team. Then we pulled in the operations team, the ones that run the data center, along with my team leading it, and said, this is what we're going to go after. How do we design this? And it's not just about how the guy can design it, it's how they build it and how they run it. That alignment was awesome. That is really powerful when you have the right people in the room making decisions together and raising their hand and saying, that's not really how it operates when you actually hand it over to me. So we get the alignment from there. And then having a target of less than 1.2 PUE average for the year. Okay? And also, they came back within the responses in these and the design. This is what PUE is going to do over a 12-month period, right? And also over a load period at 20% load, 30, 40, 50, and all the way back up to 80 or 90. Okay, so what we're trying to get to is a minimum or a maximum of 1.2 at 80% load of our center. We're actually achieving that even closer to 35% load now. It's great when everybody aligns. Free cooling year-round in Arizona. That drove some interesting behavior too. Everyone had to think, how do you go deliver free cooling year-round in a place that goes over 120 Fahrenheit? Also, we have containers on the roof exposed to the sun. We're getting free cooling year-round in those two. Everybody had to rethink and drop the assumptions and start again. How would you approach this now that you got a green field that you're going into? And then we realized scaling this infrastructure-wise in 2 megawatt chunks made a lot of sense. So we're adding 2 megawatts of infrastructure, consume it to a certain point, pop, we do the next 2 megawatts, and we keep scaling up from there. The other key was the site is built for end state, meaning that we're not just building up to here. We're not building 4 megawatts. We're building to 12 megawatts of IT, and we're deploying 4 megawatts first. And we've already kicked off the next 2, but it will scale to 12 over time as we need it. Okay? Next one, TCO is a decision maker. I was mentioning before, consolidating those SKUs was not a very easy thing to do at the beginning because everyone wanted their configuration. They loved their server type. They wanted to hug it. They wanted to own it, etc. Pulling that away and saying, once we map this in a matrix, CPU, network, storage, right, all those components together, we realized there's only 3 or 4 pieces that were different. And we asked, why were they different? Well, I need more memory on this one. I need more bandwidth on this one. I need more interfaces on that. When we started to find the common ground, suddenly cloud, search, Raptor, all these other things just work. And so we made an investment to upsize memory across the whole thing because it now meant we could buy all the equipment and move it around to different apps. That agility was extremely important for our infrastructure because now when the business changes, we can adapt with it like that versus, we got to buy a whole other lot of 2,000 servers to do this function. The standardization, the purchasing I was talking about with it streamlines the supply chain. That useful life part, I love this because we've talked about this for years. If I have a hardware purchase for 3 years, okay, it's going to be used for 3 years. I may have parts in there that can only be used for 2 years because we had leased equipment before for 2 years, and this was for search because the CPU performance, basically following Moore's law, we wouldn't get enough performance. And we could justify replacing all the equipment after 2 years to actually now put in new equipment because we would cut our wattage consumption in half and we would double our performance. So we use less equipment. Now we're purchasing equipment because the TCO made sense. But I can take that equipment and repurpose it to something else after 2 years and just keep augmenting the infrastructure with the next gen of SKU. All right, so the packaging, as we were talking about, now having a standard rack with the components I talked about, a standard container, we can start to get lots of things in the supply chain very quickly. Once all these things came together, this was great, because when I listened to John yesterday and Mark up here, and they said, hey, the tool's up, and you guys should look at this as members, I didn't even know the tool was out yet. I had gone through the PDF, and I'm trying to map these things and literally put something here that you guys could see. But then I went to the tool and plugged in Phoenix, Project Mercury, that building, into the tool, and it looks like this. This is great. It's so simple, all right? It makes you think. Notice the black bars? There's certain areas in there that, you know what, that's just not applicable. I wouldn't have a yellow part in there because, you know what, we use free peering on the network side. So utilization of my network, I don't want to get to 60 or 70% of that. I want to use free peering because it doesn't cost me anything, and I want to use the minimum bandwidth that I'm getting charged for. So there's a lot of dynamics in here, and I think things we can expand on the actual DCMM going forward. But this is a great way. You guys should go put your data centers in here because it's a simple way to understand the whole picture and where you sit. Notice the yellows. I also want you to notice a couple things here. How many level 5s are in there? The paper calls this out, okay? So understanding your applications, where that maps, pop. I don't remember which one it is, but it's right there. higher temperatures, we're getting free cooling year-round. That's in the air conditioning side. I mean, there's just a number of these things that, it's a gauge of how well we're doing. Very nice. Okay, so let's go into Mercury just really quick. This is a cutaway of the building. On the ground floor, we have 220 rack positions. It's a white floor or white space that we can do rack and roll. So that standard rack config I was talking about. On the roof, we have containers. The entire site basically is going from 4 megawatts day one, this is IT load, to 12 megawatts over time. Okay, and we have kicked off our next 2 megawatts already. The racks can actually scale from 4 kilowatts to 40 kilowatts average. Okay, note that because I will have 40 kilowatt average over all of the racks when I hit 12 megawatts. Okay, so there's also some lessons learned in there, and I'll explain that a little bit later, but the scale was what was important. All right? And this is the white space, and notice the white. Part of the DCM talks about lighting. We chose white racks instead of black because I didn't need as much lighting, right? It's easier for the techs to do their work, etc. And also just notice the above, everything's decoupled. Rack and roll literally is rack and roll. It rolls into a position, we plug in the network, we plug in the power, and it goes. The other key part is I can now have any rack in this space have in-row air conditioning, and when they cross a threshold of a certain density, we put a passive rear door on the back with direct liquid, and when they pass that density, it goes directly into the rack. So liquid-cooled servers directly, we can put into this infrastructure with no changes. All we spent was an extra $500,000 in piping underfloor that depreciated over 30 years is peanuts. So we have future-proofed this data center to allow for 3 or 4 or even 5 tech refreshes in the environment without having to do construction. All we're doing is adding capacity outside to continue to expand this. Okay? The containers, you can see on the top here, this is the roof. Yes, it's exposed to the sun. Yes, it gets over 120 Fahrenheit. And yes, there are different sizes and different manufacturers. So there's 6 megawatts of capacity in that roof, 6 megawatts in the bottom. It's 14,000 square feet with 12 megawatts of IT capacity. 40 kilowatts of cabinet average over time. Okay? It's still half the CapEx. Keep that in mind. It's not like we're paying a premium for these things. We're just planning it out at the beginning, and it's saving us tons of money up front and as we go forward. The module shape, size, weight, etc. don't really care. We have a grid on the roof that allows them to snap in. We left it generic. Just like rack and roll, we could roll those things in. We are using adiabatic and hot water cooling. This is getting our free cooling year-round, both of those technologies. And of course, 6 megawatts on the actual roof itself. Here are 2 container examples. The paper is vendor agnostic, right? So I don't have any of the vendors' names up here. You can fill in the blanks wherever you want to. But what I'm showing is, on the left side, the lunar lander, that's 2 modules. If you notice on the right, this is the second module added onto that. All those are servers, okay? We just haven't put the other pieces on yet around it. The one behind it is complete. That one, using adiabatic cooling, now will look like this one. But we're talking 550 kilowatts going into one of those containers, 1,920 servers in a 40-foot rack capacity space. Okay? Extremely dense. And on the other side, we have other modules, and these are more of a rectangle versus a square. Okay, but they both have the same capabilities. One's using hot water cooling, one using adiabatic. Whichever gives us the best transactions per watt is what this ultimately comes down to, is the one we're going to land up there. Every time we land a container, we're putting an RFP out who's going to give us the best performance, TCO-based. Great. It's flexible, and we can keep landing this capacity. All right, now let's get to some numbers, okay? PUE. I love this because it blew my mind. When I saw the results of it, I questioned them. I actually went back and said, your decimal's wrong, or there's something wrong here. It can't be this low. It was August 23rd, 2011. We had landed the container on the roof, all right? And the only thing I'm showing here is a partial PUE because that's what we were testing. It was the middle of commissioning when we were doing this. It was 119 Fahrenheit on the roof measured. 119, okay? And we had the container under full load. We pushed it to its absolute maximum. Then we dropped it down. You see those numbers? This right here is the low, 1.04. Remember, it's 119 Fahrenheit outside? Okay? We have 1,920 servers in there. It's 26 kilowatts of cabinets sustained at that point, and it's using outside air to cool. All right? Then, at the mid, and that's the maximum that we're getting out of that container in the worst possible conditions, because it had slightly rained that morning. Okay? 1.044 for an extremely dense environment on the roof exposed to the sun. They blew me away. What I was looking for was the ability to have free cooling year-round, and we got high-density packaging and outdoor components. This changed my mind on a couple things, as I talk about in the top 10. You'll see in a minute. So after this, we started looking at the overall site. So now we were in commission in January, and okay, who here has ever done level 3 PUE measurement? Except for my staff. Thank you. One person in the room has done level 3. I will tell you, it is extremely freaking hard to do level 3. Why? Because everything has to work, right? These guys were pulling their hair out trying to figure out, well, wait, so I've got these actual breakers that are wrong. I got PDUs not working. And things aren't communicating. We spent, because we were trying to release this paper in December, but we weren't going to release the paper unless the numbers were actually correct. And so we spent months going through all that data and fixing things and tuning things and fixing it again and changing out components until we got to this number. So in January, we were able to actually run it for a week, continuous, and come up with level 3. So the best for the site was 1.26. Okay, the high for the site was 1.35. The load on the site maximum was 35% of 4 megawatts of capacity. It's blowing me away again. When we're getting to 1.2, right, that's what the design was at 80%. We're already getting it down there. But here's the other part. Look at the numbers of that same container. Sorry, let me go back here. At that same container running then, when it's colder outside. Okay? The one that I was also just trying to scratch my head over, 1.018 in a container on the roof exposed to the sun. It was colder outside, but that's idle equipment. You would think it would go the other direction. Idle equipment's going to be less efficient because the fans aren't optimized, etc. The damn thing just kept going like this, like this. It was just optimized completely. What did that mean? Our overall site PUE, those numbers above, right? Those numbers right here, went down because of containers. Because those numbers are in here. So even if our white space is less efficient, the containers are making up for part of it while we're lightly loaded. And standard SKU is the reason. This is all the same kind of equipment, right? All rolled out inside of that infrastructure. So Project Mercury for us delivered incredible value to the business because we've been able to keep our costs under control. We've been able to simplify the infrastructure. We've been able to get ahead of the demand. Those are huge things when you think about the first business driver slide. The business is growing like mad. We got things thrown at us. We're not reactionary as much anymore. There's still things to be fixed, but this is allowing us to actually optimize the business. Okay? The other thing is, all these lessons learned, we are now applying to Project Quicksilver, which is phase 2 of our data center in Salt Lake City. If you guys have ever heard me speak before, that was Project Topaz that we opened up in 2010. Now we're going to go to scale with this. Because this was a small data center optimized for that size in that plant. Now we've got 15 acres. What do you do with 15 acres? Okay? Excellent. Well, thank you very much for your time on Project Mercury. I'm going to ask you to hold your questions for a second. We're actually going into 2 sessions, like I was saying, the top 10 from Data Center Pulse. On Monday, this is our 2nd annual Green Grid collaboration session with the Technical Forum. So Data Center Pulse, what are we first? Data Center Pulse is a bunch of end users coming together to actually collaborate and share information and hopefully influence the industry based on the things that they consume, the ideas they have, the problems they are trying to solve, putting that back out to the industry. The reason we have the top 10 is to give every vendor in the room, anybody creating products or services or solutions for people like us, insight into what's important. Okay? So we've got now 2,271 members in 66 countries, I think it is. Okay, that represents 1,000 different companies These are individuals at all different levels, from mechanical engineers back up to CIOs. There's a great mixture of those people inside of the room. Okay, so on Monday, we had our summit, and what we do with these is we bring people together and they choose the topics that are important to them. So the top 3 that came out was Project Mercury, because it encompassed so many different things that were going on. We went into depth for 3 hours on Project Mercury. And can you imagine a bunch of engineers from all these different companies? I'm talking Microsoft, Yahoo, Salesforce, right? Equinix, a whole bunch of these companies in there, challenging everything, asking the questions, why would you do this and those things. It was awesome. It literally was awesome. And these are some of the most rewarding sessions for me, because it validates and also questions and challenges your thinking on so many levels that you have to really now think, oh, how would that apply in my environment? Would I change something here? But also, yep, that was the right decision. Or nope, that wasn't the right decision. We also share the things that went wrong. Okay? So I'm talking about level 3 PUE. Why was it so hard to actually get? Okay? Decisions about infrastructure and other components that were great lessons learned for a lot of the folks inside of the room, because we went through the pain. We want to share that, and they're sharing pains back with us that they've already seen. Okay, so you can take a look at datacenterpulse.org/join me if you're interested. If you're an end user, we are kind of very tight about who is an end user, all right, because that's really what the value of the group is. I'm going to also step you through really quick. We started this in 2009 at the very first Data Center Pulse Summit, back when I was at Sun Microsystems. And we hosted it there and brought people together. And I see faces in the room of people that were actually there, Michelin and a number of other folks. This is what we came up with before. And I won't go through these, but what you see to the right is the progression. So we went from this type of top 10, and the orange ones were changed in 2010. I remember the 451 group had bought the Uptime Institute, and I think is it Skip, or I forgot the guy's name, who runs 451 group? Martin, yes. Martin sits down to me and goes, yeah, I saw your update. And he said, he goes, so dump the tier levels, huh? I said, yeah. Let me explain why. So we modified this too to update the tier levels to represent the current data center environment. That's the kind of thing, and those are great conversations to have. They want to know, right? They change things based on what? End users' application or feedback on what is going on. Okay, I won't go through the other pieces here, but now you can see from 2010 to 2011, we were changing a couple things. Now, from 2011 to 2012, we've actually changed over half of them. All right? And I'm going to go through these individually. And they are in order, based on the stuff that was going on Monday. Okay? And I'll summarize this at the end as well. The very first one is we went from industry alignment to facilities and IT alignment. I'm putting this back on my community, because the reason we all have such a hard time doing things is that internally facilities and IT fight. You can't get to the efficiency unless you've got the right people at the table that can actually have the right conversations and change the behaviors. So the big guys have figured it out. Why have they figured it out? Microsoft, Yahoo, Google, Facebook, eBay, I mean, think of that. It's because the volume of stuff that we buy and the costs are visible to the CFO. Suddenly there's a lot of scrutiny, and you start to look at it and say, why is that? That organizational structure allows us to truly go after the same goal. The other side is the performance is lined up with the CIO, the technology is with the CTO, and suddenly data centers and infrastructure become critical to the business. The C-suite starts to care about it. Okay? That's where I want the small to mid-sized data centers out there, which probably represent more load on the infrastructure than all of the large data centers combined. Okay, I know that sounds a little far-fetched, but it's real. There's tens of thousands of these things out there, okay, of companies that do this, and there's hundreds of thousands of them outside, right, or of data centers themselves. Okay, so once we get this alignment, we're going to get better products and services, because we can truly solve the real problem. You think about the containers and the standardized SKU we did. We suddenly solved the business problem of performance of IT infrastructure and gave optimum performance of the mechanical electrical inside. All right, second. That's a little hard to see. Simple top-level efficiency metric. We've asked for this for 3 years now. I'll cut to the chase. We turned it around ourselves again and said, so there's all this work going on inside of the industry, but we haven't made the progress with it. Why don't we have a miles per gallon measurement? So we actually took real data from one of our companies, and we sat down and came up with what that metric looks like, okay? So we have a miles per gallon proposal internally that we went over on Monday. That was the number 2 topic everyone wanted to hear about. Okay, so there is great alignment here from a green grid standpoint. Because I look at the productivity metric and what's going on there, it's this way, going up technically on all the different layers of what they are. This one, did I hit something? Okay, this one is top down. This is a business metric. What's important to the C-suite? What will drive the right behavior and change in the business and goes this direction? Those two will converge at some point because they still need all those specific engineering metrics underneath of how they represent the numbers going up. But we need a top-level miles per gallon one. We don't have the details to share out with you yet. Trust me, there's a year's worth of data looking at all this stuff already. We have trends across all of that and great discussion and debate with the actual data center pulse members. Okay? This ties into 3 different things: performance, cost, and the environment. Once you have transactions per watt, work that's done, you can say cost per watt, you can say carbon per watt, you can say all those different things. It becomes very easy to make this extensible to all those different business drivers and needs. Okay, one other part, this will be a proposal. It took PUE 5 years to get there. Okay, we all have gone down this road. It doesn't just come out and say it's the answer. This is what we're going to get to. All right, the next one is Stack Framework, and if you haven't seen this before, this is something we were developing to help facilities and IT people actually have the same language, to understand the layers and how they communicate and how they're connected. Okay, and so we've seen this come back in proposals and all types of things that people are helping to have the conversations across the borders, and this will align us back in with facilities and IT coming together. We're still doing the work on this. Move from availability to resiliency. Tier 4 data centers don't solve all the problems. Resilient applications are where everything is going, which means, like you heard, Tier 2 data centers become absolutely applicable to the applications that are running for 80% of our environment, et cetera. Okay? So I won't go through this. We're running out of time. Renewable power. I'd like to bring this up right now. There are not enough choices in this country for companies to pick from. There are not opportunities to get clean power that are cost effective. Okay? The reality is companies choose a location, and when they do that, it's a long-term investment. If you're in that place, you need to solve it in that state. You need to solve it in that province, where you are, unless you're going to pick up a couple $100 million investment and move it somewhere else. But anybody citing a choice in an area, there's no reason you can't go back and actually ask business development, the economic development groups inside of each one of those states, governments, that clean power is a priority for you. Okay? I will tell you in one region where we are, it's illegal for me to invest in anything in renewable power off of my property. Okay? That's from a law in 1939. It is, seriously, and it's a regulated environment. So suddenly it's extremely difficult for me to get what I really want. That's a corporate priority for us. But I can't get there without legislative change. So you can imagine what we're doing around that front. Okay? So, renewable power options, extremely important. Another part is containerized versus brick and mortar. As I said, those containers, this was a great discussion inside of the group. 5 years ago, when the first containers came out, we were saying, this will replace data centers. You can just put them in a parking lot. Okay? And everyone's like, oh my God, that doesn't seem viable, et cetera. It took 4 or 5 generations of products and now results of those things to say, I might actually be able to run a data center in a container. Okay, and I say container in quotes because it's a module, but it's, it's not just an ISO container. It's a box of some sort. That is absolutely come back around to the same argument. What do I build? And that goes into the next topic. Hybrid data centers. Do we build brick and mortar data centers that have raised floor space to deliver racks? People are starting to really consider, I could have containers, I could have racks, I could have a hybrid environment, multi-tier. Suddenly all these things start to change the way that data centers are designed. Okay? That's very important for the people that do engineering work and architectural work. How could you go back and deliver business value to them that continues to cut the cost, gives you agility around multi-tier, and allows you to now take on the next technologies that are landing in it. The folks that are doing all-air data centers, I commend you. It's great. It is the right answer right now. What happens when we go forward and there's liquid-cooled equipment? Okay? What are those changes? Do you have to rebuild a data center for it? If you have a modular solution, you might be able to just land a container that has that stuff in it. Hybrid. All right, next one, liquid-cooled IT options. I keep lining right back up to these. The leading indicator of what's going on is the high-performance computing environment. If you look at anything out there, I know there's a 100 kilowatt install. I think Clustered Systems did one with one of the HPC. 100 kilowatts in a cabinet, okay? All liquid-cooled. Interesting. So why would they do that? Because they're trying to get the maximum performance out of that equipment. What are we doing in data centers? We want to get the maximum performance out of the equipment. I'd like to use the smallest amount of equipment to do that as possible. We start to hit the ceiling of air. There is a ceiling, and we found it's 28 kilowatts with a certain amount of area in a container. Okay? 28 per cabinet. All right, the next one is free cooling everywhere. Let that sink in too. We just proved that we could get free cooling in a desert with temperatures reaching 119 and above Fahrenheit. Okay? That is aligning the vendors and the warranted equipment actually operating in those environments. The next challenge here, why can't we do that everywhere? Humidity is another big one. Great. Then the challenge should be, why won't we get 100% humidity? A solution for that in Singapore. That seems to me to be the worst case scenario. Once the temperature's there, now it's about the humidity. How do you solve that? Okay? Free cooling everywhere. Everybody should have that on their mind. We should be figuring out how to do it. The next one, converged infrastructure intelligence. This ties the whole thing together. The infrastructure itself, the data center, has become a complex IT system. Okay? When we were measuring PUE, 1.5 billion measurements over 1 month in Project Mercury. What the hell is that? Okay, 1.5 billion, that's not a joke. So those numbers, we're thinking, oh, okay, our frequencies might be, we shouldn't do it every 7 seconds on everything. We should be doing it maybe 5 minutes here, 15 minutes. But the point is, figure out that. The infrastructure now needs to go up the stack. Well, you have to connect all that into something that allows your IT applications to map and control the environment. That's all coming. Okay? Great. So this is the top 10 list. My formatting got all screwed up. But this all came out of literally 3 or 4 years worth of collaboration with my peers. Okay? That's really, really important here. So is this the answer to everything? No, but it is absolutely the pulse right now from the active members inside of Data Center Pulse and all the activities, conversations, and collaboration that's been going on. Okay? So thank you very much for listening. I think we have just a few minutes for questions.
Yeah, we got almost
10 minutes.
How could that?
My goodness, how did I do that? I usually talk too much. Great. And if you could tell me your name and who you're with.
Sure, Nicole Peel-Malter from Akamai Technologies.
From Akamai?
Akamai, yes.
Ah, okay. I'm a customer.
Yes, you are. So I was curious about your server utilization, and because right now it's, when servers when they're idle, they're still drawing a lot of power. Mm-hmm. Have you considered putting them in a low power state or turning them off, or somehow increasing your server utilization to a higher level?
Yeah. So let me go to the metric I was talking about. Okay. The proposal here is service efficiency metric. I want to get away from, well, I should turn these servers off and my utilization is this. I want to look at my entire infrastructure as an engine and how much I'm consuming in that engine. Okay? You think of a car in miles per gallon. Well, it gives you an average of what it's going to be, but it's your driving behavior. So utilization on a server, network bandwidth, all those different components are your gas pedal, figuring out what that is. I would like to be able to have a measure that drives that specifically. I want more transactions. I want less watts. The transactions are the miles. Right? The watts are the gallons. We want to be able to get to that point. So that's one knob that you can turn inside of your infrastructure. Data center consolidation is another one for a better PUE. Technology refresh is another one. Code optimization is another one. All of those knobs should increase your actual work out, okay? And lower your watts, or both. So I want to up-level the conversation once it gets to the C-suite, and it becomes critical for them to understand my cost per watt of what I'm doing is this. My revenue per watt is this. My carbon per watt is this. Based on what is important to you, you really have a picture of what it can be. You get a baseline of that, an average for the year, just like PUE has. It goes like this all over the time. but you still have where you are, then the targets can be driven down at a C level, and you can actually justify what spending you're requesting to go do what? Get more transactions or lower the watts. Make sense? Okay?
John with 451 Research. What is cost-effective renewable power, and how can state governments help you get it?
Okay? So data center owners and operators right now can't solve this problem. So that's a great question. So I will tell you internally, we've done a lot of research on how to solve the problem. No matter what, I have a cost per kilowatt hour that I need to keep with, okay? My infrastructure, because it's another component of overall cost. If I had the ability to do a power hedge over time, I would do it. Right now I can't, in the reasons we have. If I had an investment I could make that I may pay more up front, but still gives me 20 years of flat power costs, why wouldn't I do it? If it was 100% renewable at that point, why wouldn't I do it? Guess what our criteria is? Any investment must be renewable. It must lower the carbon footprint. Okay, so what I'm saying is, in the States, okay, or in Asia and other parts of the world, if you don't have access to clean power, that's going to be cost effective, not 3 times the cost. Right? You're not going to do it because you can't justify it up to the C-suite. The business development or economic development groups inside of each of the states try to attract people and companies to do what? Create jobs inside of a state. Their underlying infrastructure, just like the roads, their schools, et cetera, the better it is, will attract more people. If there are renewable energy options that can be had within that place, you will be able to attract more businesses. But you're the barrier to entry if you're saying, all I care about is the lowest cost of my utilities, and I don't care about how clean it is. There's got to be an answer. And guess what? When you bring utilities together and governments together and renewable developers together with customers of that power, magical things start to happen because there are answers, just like the data center. When we brought all those people together to design it, it's the ones that have to run it to the ones that have to design it. Incredible uber efficiency comes out of it. I know there are answers inside of the power grid if people are actually sitting down and trying to figure them out. My personal opinion, but I know it's there. Any other questions? Quick, run.
Do your the facilities and IT alignment, how broad do you view IT? Does that include all the way down to the developers?
Okay, so who are you?
Mark Agar, Microsoft.
Okay, so I look at this 2 ways. What I was mentioning before, if this metric can actually measure the total infrastructure,
yeah.
Okay, that includes the code.
Right.
So I'll give you an example. At eBay, we went back and tuned one pool of servers, okay? And what they did with that pool of servers was they said, well, how much memory is used for this application every time it's doing that transaction? They said, could we lower that? This small amount of every one of those transactions resulted in removal of 450 servers from that pool. Okay? Shrinking the memory, so tuning the app to only use what it needs right there, shrunk that 400 plus servers, right? It avoided technology refresh for those servers. Yeah. Over $2 million worth, okay? CapEx. On the other side, it avoided almost a megawatt of power consumption. And that equated to over $1 million in OpEx on my side. So yeah, these little knobs that start to turn have really big effects on the outside. The only way to do that is when the developers see that it's important. And how do they see that it's important? They're actually measured on what they write. Yep. Just like the data center is measured on how efficient it is. Just like the IT equipment is measured on what performance it would have. I want to get away from all these other pieces underneath, all the microcosms of what we could do, and going back to the macro level and say, what's the value to the business? How do we drive the ultimate efficiency, but also that turns into revenue? Because that's what we're here to do, right? Is to try and make a business that delivers for the customer's demand. And I think now you have thousands of knobs, and enabling all those people to turn those knobs and see the result is where you really get transformational change.
How do you handle scenarios where you just don't have the transactions to work on because people are asleep, for instance?
People are
people are asleep. So I assume a fair amount of your load is actually driven by live human beings.
Yes.
So what do you do in those scenarios? Are you doing extra work that you would have done?
It's another knob. Okay,
right.
So If you look at eBay transaction volume, it's like this.
Yep.
Guess what? It's Europe and America's overlap right
Right.
here. Peak of the peak is over that. But you look at those curves. There's two ways to do it. I could either horizontally shrink it, the amount of servers doing that work during that period versus this period, okay? Or I could slow my CPUs down.
Right.
I could increase my CPUs at different times. Or I could do both. But guess what the ripple effect is in all of that? Because shutting off the equipment, shrinking the pools, that's addressing directly
Yeah.
what you said. Mapping to what the actual demand is.
Yes.
But if I do that, can the data center handle it? This is a power and cooling thing. If I'm increasing this frequency in all my servers at that point, I'm increasing the actual power draw, I'm increasing the temperatures and everything. That whole ecosystem needs to be together. And the only way that is when you have facilities and IT
Yep.
organized and aligned to be able to look at the whole picture.
Exactly.
And then a measure to be able to say how well it's working.
Cool. Thanks.
Great. Any other, sorry, yes, Gary.
Hey, Gary Cook with Greenpeace International, and nice presentation, and congratulations on your success in Phoenix so far. Picking up on John's point and the point you made about opportunities for the sector to engage state utilities and state officials.
Yes.
Love to see more of that. I guess, what do you think, what's the path forward in doing that? And I guess you're pointing out, highlighting as an opportunity for, I guess, individual companies to pursue, but would certainly think there's opportunities for a more collaborative effort within the sector among, you certainly have clusters of companies in many geographic locations. What's your thoughts on what's holding that back, that conversation, and how can we advance that? Because that's something we'd certainly be interested in trying to help contribute to.
Absolutely. So, great question. What's stopping all this? And I've got 5 minutes to answer it. No. I think the reality is when you don't have the right people talking, nothing gets done, right? Everybody tries to do a lot of different things. The reason that it was brought up in the top 10 this way was I've personally had some of these conversations, right? I have extreme frustration that it's out of my control. I represent half the carbon footprint for eBay, okay? And in the regions where we are, because of the data centers, where we are, that carbon foot is growing. That footprint's growing. Why is it growing? Because our business is growing. But I have limited options in what I can go back and get from a renewable standpoint. I will also tell you, I was willing to pay a premium for power. Because our efficiencies, as they went down, right, we were drawing less, that delta can be applied back in to get me a power hedge. I would pay more money for power if I could get clean power. The problem is I could not get direct clean power. When they're giving me carbon offsets, that's not solving the problem. I don't want to buy somebody else's efficiency. I want my own, right? And so what we look at is for every watt that you're consuming, there should be an avoidance on the grid for it. If I could generate all my power on site, I would. The technology's not there yet, okay? So the problem needs to be addressed at the utility level. But the utilities themselves can be bound by the governmental issues within every state, right? So this has nothing to do with the customer yet. This literally is those two people coming together to say, what does the customer want? It was funny. In these conversations, they never had a customer at the table. They said, oh, this is what the customer needs. And so once we sat down at the table and started having those conversations, interesting how the conversations changed. And suddenly, well, that is important to that company. Well, you can't burden my other buyers based on what you want. Great, then we'll pay for it. It's important to us. If I can get a power hedge that gets me 100% clean power, that I have an ROI that I won't explain, but a very short ROI for that gives me a power hedge for 20 years, why the heck wouldn't I do that? It's just I have no option to do that in some of the places right now. So I'm not the only case. eBay is one drop in this pond or this lake, right, or this ocean when it comes to consumption. All the other companies that I've found have the same challenges. And so inside of Data Center Pulse, we have a lot of conversations about this. How do we go back and get clean power when it's 3 times the cost? It's because we got a chicken and egg problem here. How do we do that? I think we need to get all those people at the table and say, this is important to us. And let me explain why it's important to the business. But I need a cost-effective way to do it because I can't lift my data centers up and land them in Iceland. Is Tate here from Verne Global? Okay, so let me explain one thing about Verne Global. So it's in Iceland. It's a data center in Iceland. Sounds crazy, right? Well, guess what? There's all these transatlantic continental fiber things running to them. Suddenly, latencies are cutting shorter because it's in Iceland. They have 100% clean power. It's geothermal. They're sitting on a volcano, but the point is they still have clean power. So, and their power costs are some of the lowest in the world. Why can't we tap into the other environments that do that within the States, within Asia? Okay? We got to look at Europe. Europe's done a lot of this. Sweden, I always go back to, they've had clean power for 20 years. 20 years! Why can't we figure it out in places like the United States? Well, that's because we need to make sure we got all the people at the right table to change the environment around the governmental piece of it. There's got to be laws in place not to force you into a certain efficiency, but give you opportunities to go back and choose what you want. I want to be able to go and get clean power, and that's going to lead a lot of others to get there. But we got to make it even available to people. Today it isn't, in the majority of the United States. Okay, any other questions? And I ranted, I'm sorry. That's one of those hot buttons for me. So
That sounds great.
excellent, thank you very
Thanks,
much.
Dean,
folks.
so much.